Read the question very carefully. Two charges are there, each equal to q, are kept at x is equal to minus a and plus a on the x-axis. So let's have a look at a diagram. So let's say we draw the axis. So we have a q charge which is kept at a units to the right hand side and another charge q which is on the left hand side. Both the charges are at the same distance from the origin. Next off, we have a third charge q naught, which is equal to q by 2, which is placed at the origin. So this is its location. Then this charge q naught is given a small displacement y along the y-axis. So this q naught has been taken upwards. So when it changes position, it is at a distance of y from the origin. Now the question is, what will be the net force acting on the particle? So exactly how to do this? First of all, remember there are three charges and there will be electrostatic forces acting between them. Now consider the charge q on the left and q naught on the right hand side. So we know the formula F is equal to k q1 q2 by r square. Now since both these charges are positive, they will repel each other. So the charge q will give a force on q naught in the top right direction. So let's have a look. Watch this. So this F, the top right direction, that's the force exerted between these two charges q and q naught. And the value will be k q into q naught divided by this particular distance squared. So we need the hypotenuse squared, right? Similarly, we have another set of particles q naught and q. That q is on the right hand side. So similarly, we'll have another force acting in this direction. So top left. The question is the net force. So we need to find the vector addition of these two forces. So exactly how do we do it? Let's zoom this in the entire picture. Let's create a line over here. Now imagine, let's say some angles we assume. Let's say this angle is theta with symmetry. The other angle will also be theta. Now if these two angles are theta, I can say even those two angles on the top are theta, vertically opposite angles. At this stage, remember the key is to find the net force, which is the vector addition. So we need to break down the forces into its components. So the x component of force, this particular force will be F sine theta. Let's draw that. We will have an F sine theta and the vertical component will be F cos theta, which goes up. Similarly, if we resolve the other force into components, you will have F sine theta to the left and F cos theta on the top. So let's draw that as well. So we have a leftward force, which is F sine theta, and the vertical component of that force will be F cos theta. Remember, we need to find the net force. So F sine theta on the left is balanced out by the F sine theta on the right hand side. So the net force will be F cos theta plus F cos theta. So the net becomes 2F cos theta, right? And now remember the force. Force was the electrostatic force acting between these two charges, Q and Q naught. So the expression will be K Q into Q naught divided by distance squared. Now, what is that distance? So distance would mean this particular dotted line's length, which is the hypotenuse of this right angle triangle. So we have a right angle triangle. The height of the triangle is y, the base is a. So according to the Pythagoras theorem, we can find out the hypotenuse, and that will be, let's write it down, square root of y square plus a square. In the formula, we have to square it. So that's the force expression, which we will put in the net force. Now we have to figure out cos theta. So again, if you focus on the same right angle triangle, let's put the value of cos theta. Cos theta is base upon hypotenuse. So the base in the triangle is y and the hypotenuse was this length, which we already found out. So cos theta comes out as y divided by the hypotenuse, which is square root of y square plus a square, which we can put back into our expression. So let's put all the values in to figure out the net force. Net force will become 2 times the force, which is K q naught divided by y square plus a square, because it had a square, the square root got eliminated, multiplied by cos theta, which is y divided by y square plus a square's square root. Now, if we go back to the original question, we had to figure out the net force is proportional to which of these parameters which are given in the options. And the net force which we found was this particular expression. Now, none of the options matches because this expression looks a bit complicated. Now, that's where we have to use this data. They have given that the displacement y is very small. Y is very small as compared to a. So in the net force formula, first of all, let's simplify that. The net force will become 2k q naught multiplied by y divided by, now we have a y square plus a square multiplied by square root of y square plus a square. So if we simplify that, we will get y square plus a square to the power of 3 by 2. Basically, all we are doing is using the fact that, let's say if you have a and a root a root a will be a to the power 3 by 2. That's what we have done here. Now we use that assumption that since the value of y, which is extremely small, so y is extremely small as compared to a. So now notice in this particular expression, since y is very small, you might as well take y as approximately 0, which means now the y square plus a square will become just a square. And the denominator, which is y square plus a square to the power 3 by 2, that will become a square to the power of 3 by 2, which is a cube. Now, let's simplify the expression. The net force we get is 2k q naught divided by a cube multiplied by y. And this is your final expression. Now look at these expressions, 2k q naught divided by a cube, all of these are constants. So this whole thing is a constant, which means we can say that the net force is directly proportional to y, which is in option A. And the direction of the net force will be upwards. And since it is upwards, we are taking positive y. Had the net force been downwards, we would have taken minus y. That's why option A is the answer.